Good evening. This is Tim Troutman. I'm here at the National Weather Service in Riverton. It's good to be with you all tonight. We're gonna get started now with the third installment of our Storm Spotter training, and I just want to welcome you all and thank you all for taking time out of your busy schedules to come and participate with me tonight. And so we'll learn more about storm spotter training. We're going to talk about weather safety. We're going to talk about where to be, where not to be if a storm is approaching, how to report severe weather into the National Weather Service. We're going to have a short quiz at the end, and don't worry, it's not for a grade, but we're going to go through it together. And we're going to talk about anything and everything related to severe weather. We're going to talk about large hail, damaging winds, tornadoes, flash flooding, lightning, and go over all the safety aspects of that too. So I just want to say, as we get started, it's great to be here with you tonight. On the screen is our 800 number. It's 1-800-211-1448. Visit our website if you don't at weather.gov/Riverton. Anything related to weather, all weather, you can get on our website. We're on Facebook. Just do a search for NWS Riverton, and also on Twitter. Our Twitter feed is at NWS Riverton. So let's go ahead and get started for tonight's presentation. We've got a little time lag on the slides, so bear with me. Okay, large hail can be dangerous in relation to severe weather. And you'll see here, this was the Bear Trap Music Festival, unfortunately, August 5th, 2018. Unfortunately, a lot of folks were caught there as the festival was going on. There was a strong thunderstorm that produced pea to nickel size hail and a few wind gusts up to 35 miles an hour with that storm. So, we provided event support, lead time of about 23 minutes to event organizers. It was just a situation where there were a lot of folks there, and there was really not a good place for folks to move to. So keep that in mind. Next Bear Trap Music Festival, if there are thunderstorms in the forecast, try to figure out a good place to move to in the event that thunderstorms are expected, because not only are you on top of Casper Mountain, but you're in a location there where there's not a lot of good places to move to in the event that a strong to severe thunderstorm is approaching. So with that, this was another large-scale severe weather event. This was a severe storm that came southeast and moved out of southern Montana down into the Bighorn Basin and through Bighorn County. Golf ball size hail on July 26th there for about 30 minutes on and off. Max wind gust 79 miles an hour at Grable. So you can see, about 60% of homes in Lovell were damaged. So, it doesn't have to be a tornado to produce tornado-like damage. There were numerous broken windows due to the large hail, damaged siding, downed trees and limbs with that, very severe thunderstorm. So, this past year on the Powder River Pass, there was a tornado that did touch down. It was rated on the Enhanced Vegeta scale as an EF1. The Enhanced Vegeta scale is named originally after Dr. Theodore Vegeta. It was updated in 2007, and the scale is based upon the wind speeds that a tornado will produce when it damages items. So in this case, it did a lot of damage to numerous trees that were uprooted and snapped, and several snow fences were torn apart by the tornado as it moved through that higher elevation area. So, for those who think that tornadoes only occur in the valleys and so forth, they are definitely mistaken. Tornadoes can and do occur in the highest of higher elevations across our area. 2018, around the 1st of June, there was a pretty good severe storm that produced 2 tornadoes into Washakie County and Johnson County with that event that had similar damage to this event. KC, this is the KC tornado for those of you who may live in Johnson County or surrounding area. This tornado was caught by these folks that were filming it with their cell camera, and this was at about 5:30 p.m. The damage that it produced afterwards we determined that it produced winds ranging from about 110 to about 120 miles an hour. It was on the ground close to 2 miles, path width of about 2.5 football fields at its maximum, where it produced the most of the damage, and that resulted in, with the damage, of several trees being down and an abandoned trailer being destroyed. So, oops, let's take a look at the video here, and this is a good example of what to look for as a tornado is about to touch down and when it first begins to touch down. So they're moving along here. All this area here is your isolated lowering of the cloud base, southwest corner of that storm. This is the area where if there's going to be a tornado to form, that's where it's going to happen. And you can see in this video here, pretty good size developing wall cloud, isolated lowering cloud base, southwest corner of the storm. Out of this wall cloud toward the middle of it where my cursor is, that's where the funnel is going to develop and touch down. And you can see if you look straight out there, your funnel is forming. You're getting debris that's flying up. As that debris is flying up at this point, you can count that as a tornado touchdown. You've got significant dust and debris flying up from the base of that funnel cloud that's occurring there. So you can see it takes probably less than a minute for the funnel to make itself visibly known all the way down to the ground. So when you see that, obviously at this point, definitely you've got a touchdown. Longer the tornado's on the ground, it's going to create more of a funnel until it finally weakens and dissipates.
Can we have a good picture of this when I take down this video?
So the one thing I stress is not really a wise thing to do and that's to chase tornadoes. We have quite a bit of curvy, windy roads across the area. Tornadoes can and do change direction, speed, and motion, so that makes them difficult to gauge where they're traveling toward. So very important for you to be really just a point spotter. So here's more information about the KC tornado from June the 12th, 2017. 1.7 miles long on the track, and it was about 2 miles west of KC there where the tornado really began to dissipate. So there's some of the scattered damage from the old abandoned mobile home, and then there's some trees there that were snapped off that resulted in us being able to rate it, between that 110 to 120 mile an hour range. Well, we at the National Weather Service, there are 123 weather forecast offices across the U.S. We have approximately 4,800 employees, give or take. We started out as the U.S. Army, as part of the U.S. Army Signal Corps back in around 1870. We changed names in the early part of the 20th century to the Weather Bureau, and then from there in 1970 we've been known as the National Weather Service. Again, 123 weather forecast offices. Most larger states have 3 to 4 or 5 offices that cover each of the larger states. There are 13 river forecast centers. These are hydrologists that watch and forecast the river stages along all the rivers across the U.S. And in the spring months, of course, winter to spring, that's when the river stages can increase their height, and that's when it's really important for us to know, based upon the river gauges and based upon the forecast, if there's going to be flooding along the rivers. And that's definitely something that this time of the year we sometimes have to keep a close watch out for, especially for folks living along those tributaries. There are 9 special centers, including in Coral Gables, Florida here, the National Hurricane Center, just south there of Tampa. There is the Storm Prediction Center in Norman, Oklahoma. The Storm Prediction Center, they issue all of the severe thunderstorm watches and warnings. The Hurricane Center, they issue all of the tropical storm watches, warnings, hurricane watches, and warnings. We have an annual budget a little over $1 billion So if you take that into account, boy, $1 billion, that's a lot of money, right? Well, actually, it's not in the scheme of things. About 60% of our budget is used to pay for our employees, and the other 35 to 40% is used to continue to upgrade weather satellites, automated surface observing systems that are at all the airports across the U.S., upgrades that are needed, and maintenance to the 127 National Weather Service Doppler radars, and also the upper air balloon launches that we do every day at about 90 locations. That can be costly too. So that's where our budget really goes to each year. So we issue lots and lots of warnings for that price and forecasts and observations. And for each person, it probably takes you one trip to a fast food restaurant one time a year to purchase a value meal. That's what pays for your National Weather Service out of our tax funds. So I think in the scheme of things, we come pretty cheap for what we can provide. And that's lots of warnings and forecasts. Each weather forecast office in the National Weather Service has what's called a county warning area. That's our service area here. And the National Weather Service Riverton service area stretches from Park to Teton down to Lincoln, Sweetwater, Sublette, Fremont, Natrona, Johnson, Bighorn, Washakie, Hot Springs, and Park counties, of course, again. We cover 11 counties, and that 11 county area covers 56,396 square miles, which is about 58% of Wyoming. The National Weather Service office in Salt Lake City covers Uintah County. National Weather Service office out of Billings, they cover Sheridan County. Rapid City office covers Campbell, Crook, and Weston. And these 7 counties here toward the east central to southeast part of the state are watched continuously 24 hours a day, 7 days a week, 365 days a year by the National Weather Service office in Cheyenne. So we place the counties in a service area based upon the proximity to the radar that's nearest to them. So our radar here in Fremont County is closest in most cases to the counties that we cover here. Billings is up here, so it kind of covers Sheridan a little closer than our radar does. And of course, Salt Lake City somewhere down around here. So with that, why do you need the National Weather Service? And that answer is more than 500 Americans die each year in weather and flood events. More than 5,000 are injured. And weather and flood losses cost America each year more than about $14 billion. When I started doing this type of presentation about 25 years ago, that number was at about $6 billion. So I think there are several factors that go into this. We've been going through maybe a little more of a peak in different types of severe weather hazards. The cost of replacing homes and businesses and different structures and so forth has obviously gone up in the past 25 years also. And there's more population now, of course, across the U.S. than there was 25 years ago, which also, unfortunately, leads to more people being in the path of severe weather, whether it's flooding, tornadoes, high winds, or onshore flooding that occurs with a hurricane or a tropical storm. Those are some of the major factors that occur with each year with severe weather damage that occurs across the U.S. So the importance of us at the National Weather Service having the ability to give you all on average of about a 13-minute lead time for severe thunderstorms and tornadoes, and about a 50-minute lead time for flash flooding are reasons why we really strive to continue to improve and get as well as we can involved in the process of issuing warnings. We're the only entity that's empowered by congressional law to issue warnings for the protection of life and property related to severe weather. At the National Weather Service at Riverton, here's your bird's eye view at our operations area. We have 15 meteorologists that are dedicated to public safety and are always monitoring the 11 counties across our area 24 hours a day, 7 days a week, 365 days a year. We always have at least 2 meteorologists on duty 24/7, watching the weather, issuing forecast updates, and the necessary warnings as needed for protection of life and property. You as a storm spotter are very important to what we do at the National Weather Service. Without your eyes and ears to the ground there, giving us that storm spotter report in real time, well, how do we really know for sure how well we're doing here at the National Weather Service? Of course, we are especially trained to know what to look for in relation to a developing severe storm, and we will issue those severe thunderstorm warnings, tornado, flash flood warnings as needed always. But it's important for us to get verification involving what's really going on out there so that we can match that up to what we're seeing on the radar. So, good spotter reports in real time based upon what we're trained to look at on radar should equal timely and accurate warnings. So you can see across our area, we do have quite a few spotters, and a lot of the spotters obviously are in towns across our area, but we do have some spotters that are in the rural areas, and that's very important because we do from time to time have quite a bit of severe weather that are in some of the unpopulated areas, which makes verification of tornadoes and large hail and damaging winds and flooding more difficult. So, the more we can get as far as spotters out there, the better off our job will be here at the National Weather Service. And I can say, as with my experience, each day is different as you move through the spring into the summer months, involving the outside environment. So what may take one day enough moisture and instability and so forth to produce severe weather today, it may be different tomorrow. So that's why we really need to gauge reports out there with what we're seeing on the radar to help us make that informed decision. Well, the Doppler radar here at the National Weather Service at Riverton is located northwest of town, about just a few miles at about 5,500 feet on top of a pretty good size hill here. We're as a crow flies, about a half mile from the Riverton Airport. Nationwide, there are 158 WSR 88D dual polarization Doppler radars in operation across the country. Notice I said earlier 127 are National Weather Service. DoD, Department of Defense, has about 31 other radars that are at Air Force, Army, and Navy bases and Marine installations across the U.S. And we're able to utilize their data also to help us fill in some of the gaps and holes that are out there. Unfortunately, here in Wyoming, there are a few gaps in the radar coverage, and we unfortunately don't have any, per se, large military installations near those areas. But the one thing I just want to say is the Doppler radar, it is definitely what we're going to be looking at in the process of the event. So when you're looking out your window, as this person did on August the 30th, 2010, when they took a picture of this tornado approaching likely from the southwest, moving toward the right-hand side of the screen there, when they're seeing that, they're going to call that into the National Weather Service. Well, we're going to be looking at the Doppler radar, and we're going to be seeing on the Doppler radar winds blowing inbound toward the radar, which is this green shading here, winds blowing away from the radar. So where the green and the red and the counterclockwise motion that I'm showing here with my cursor is indicating, where that green and red couplet is located is about where that tornado is occurring, as you're seeing that at near your location. The Doppler radar also allows us to measure the strength of the water droplets and the amount of the water droplets within a thunderstorm. So looking at the radar, the green shading is your light precipitation, your yellowish shading is heavy rain. When you get to the red, the dark red, that's very heavy rain. And then when you get into the purple, the really white to the purple areas here, that's intense precipitation. From my experience, when you're looking at this area right here, that is your hail core. That's where the storm is situated, where the large hail is occurring within the vicinity of this whole area right here. And a little bit back to the west of where that largest hail is occurring, which is about where my cursor is, there is a kind of a fish hook like of an echo here of the most heavy, intense precipitation. So kind of where that south end of that fish hook is going to be where your tornado is going to be located, right about there, and matching up with right there, and then you're seeing that at your location. So radar plus spotter reports should equal timely and accurate warnings. When you're looking, at the National Weather Service, we are at the Doppler radar, and as the beam is shooting out from the radar and looking in all different directions there as the beam shoots out. The beam shoots out and it spreads out with height here. So you can see the beam starts smaller and increases in size and spreading outward as the beam moves further away from the radar until it's really high up into the atmosphere here. So really the best location, to give us the optimal way of looking at storms will be somewhere in this sweet spot between about 20 miles to about 80 miles or so from the radar. You're going to be probably able to see what's going on in the lower levels of the storm, where that isolated lowering of the cloud base, southwest corner of the storm, could be producing a funnel cloud, and if that funnel cloud touches down, could produce a tornado. Well, are we going to be able to see what's going on in the lower parts of the storm when we're out here around 125 or so miles? Are we going to be able to see what's going on down here in the storm? And then the answer is no. Unfortunately, we're not. Now, we may see a lot of that counterclockwise rotating updraft, a lot of strong winds to intense winds up here in the mid to upper levels of the storm, between about 15 to 30,000 feet in the atmosphere. That may give us enough of an indication that, wow, if we're getting 100-mile-an-hour plus winds up here, what's going on in the lower levels of the storm? So that's where, due to distance and that limitation, that's why we need as many trained storm spotters as we can, with distance away from the radar. Your spotter report can help verify for us, well, we've got the really strong to intense winds aloft, and we're getting a report of isolated lowering of the cloud base, southwest corner of the storm. Funnel is forming from the cloud base area there within the wall cloud, and as that funnel touches down, becomes a tornado. So I want to talk to you now about definitions and terminology. The first time I gave a storm spotter training class about, probably close to 30 years ago now, when I was 12 years old. No, I'm teasing. I asked the crowd, I said, what's a watch? What's a watch mean to you? And the fellow said, what's what you tell time with, isn't it? And I'm like, well, of course, but in relation to severe weather, a severe weather watch means conditions are favorable for a severe weather event in and near the watch area. Ideally, hopefully the watch is put into effect about 3 to 6 hours in advance of when the severe weather strikes. Now, it doesn't always work out that way, of course, and weather is still an inexact science. Notice in watches, we say in and near the watch area. It's getting more and more closer to 100%, but it's still not quite there yet. So what happens when a watch is needing to be issued? The Storm Prediction Center in Norman, Oklahoma, those are meteorologists that are, they're specially trained to watch the entire U.S. And they try to figure out if there's going to be an organized area of severe weather that's going to occur on a particular day. Well, when they figure out over a particular area that there could be, a larger scale area where severe weather could be happening over the next 3 to 6 hours, hopefully, they would, in effect, then get in touch with the offices of the National Weather Service, the weather forecast offices that will be potentially, also affected by the severe weather that day, and would be needing to watch the area closely for severe weather. So what we'll do then, the Storm Prediction Center will get on a conference call with the affected National Weather Service offices potentially. And, typically in our area, if there's a severe weather event and we get on a conference call with the Storm Prediction Center, It will likely either be Pocatello, Billings, Salt Lake City, Cheyenne, maybe Rapid City to the northeast of us that would be on the conference call. And then within that conference call, they'll discuss whether there's a need for a severe thunderstorm watch or a tornado watch. If there's more of a threat of large hail and damaging winds, they'll just simply go with a severe thunderstorm watch. And that means large hail, damaging winds are possible. If there's more of a threat of tornadoes, then the Storm Prediction Center will go with a tornado watch. So, at that point, we'll decide with the Storm Prediction Center based upon our local knowledge and their overall knowledge, which counties need to be in or out of a particular type of a watch. As we all know, severe weather has to start somewhere, but it also has to end somewhere too. And our objective is to be as precise with that so that we don't, keep people in a watch for 6 or 8 hours, and there's no chance of anything occurring. We don't want to do that. We want to get as more precise and accurate and timely with, our forecasting in relation to severe weather as possible these days, which we should with the technology that we have. So when a watch is issued, if it's a severe thunderstorm or tornado watch, we're bringing up our spotter network. We're also letting the emergency management in each county know that the severe weather threat is going to be imminent, potentially within the next few hours. So a watch means get ready, get set. It doesn't mean go yet. It means keep a close watch to the potential for severe weather. When in fact the storms begin to develop and we begin to get, strong thunderstorms setting up, and it looks as like that storm is going to produce large hail and damaging winds, then we'll issue a severe thunderstorm warning. And when that severe thunderstorm warning is issued, that means severe weather is imminent, large hail, quarter size, 1 inch in diameter or greater, damaging winds 58 miles an hour or greater are considered severe. If the storm then shows signs of really a good, strong to intense counterclockwise rotation, and at that point, we begin to get a spotter report of a isolated lowering of the cloud base, southwest corner of the storm, where there's little or no precipitation occurring. If within that wall cloud, the middle of that wall cloud, you get a funnel that's forming and looking like it's going to be more than halfway down to the ground, well, that's a very important report for us at the National Weather Service to receive from our trained storm spotters, because based upon that report and based upon what we're looking at on radar, at that point, we better be issuing a tornado warning. So again, a warning means go to your safe location at that point. And wherever it's determined that you think it's a safe location, move to it at that point. We issue warnings for tornadoes, severe thunderstorms, flash flooding, and also river flood warnings too. So keeping that in mind, a severe thunderstorm is going to produce, one of those 3 main items there, which is a tornado, hail 1 inch in diameter or larger, which is quarter size. When you get up there above dime size is 0.69 of an inch in diameter, penny size is 3/4 of an inch in diameter, nickel size is 0.88 of an inch in diameter. So, if it starts out like pea size and then increases in intensity, and you're reporting that into us at your location, then we see a little further down the road that the storm further intensifies. Then at that point, well, we better be issuing at least a severe thunderstorm warning. So when you get above quarter size, 1 3/4, of course, is golf ball size hail. 2.5 inch is baseball. And then when you get up there above, 4.5 is softball. 6 inch in diameter hail, if that ever happens. That right there is a CD size. Hopefully never bowling ball or basketball size, right? No, don't want that. Haven't any reports of that yet. Hope we never do. Wind gusts 58 miles an hour or 50 knots in aviation terms. That's considered severe. Notice we don't have a nice round number there. It's not 60 or 50. Well, in aviation terms, 50 knots of wind, if you have a Cessna plane flying along And if that plane gets hit by a 50-knot gust of wind as it's flying into a thunderstorm, well, that Cessna plane is going to be forced down, and potentially there could be an aircraft accident. So we view 50 knots of a gust of wind, that's going to really start to begin to produce some structural damage also, snapping off some trees, doing some minor roof damage and so forth, maybe some damage to an outbuilding. So that's what we consider the lower end of severe and damage in relation to wind gusts. So, the best way to get your warnings with the National Weather Service is by utilizing NOAA Weather Radio. NOAA Weather Radio is our national warning radio system. We issue, it's all hazards involving warnings that we issue on the NOAA Weather Radio. It is the voice of the National Weather Service. We have 14 transmitters from up here at Mammoth to Grant Village, Jackson, Afton, Kimmerer, Rock Springs, Pinedale, Lander, DuBois, Thermopolis, Casper, Casey, Worland, and Cody in our service area. 14 transmitters that we monitor, and also utilize to issue severe weather and forecast information on there. You can get your warnings with the weather radio any time of the day or night, 24/7, 365 a year. When you're out and about camping or doing outdoor activities like that, if you have a portable one, take it with you. It may give you that severe weather warning where you might not get that wireless emergency alert via your cell phone, just due to the fact that in some areas of the state, of course, cell phone coverage can be definitely, as we all well know, spotty. So keep that in mind. Most weather radios are about $30 or less, and you can get those online and so forth. And probably the most popular one, I can't tout one over the other because I work for the federal government, of course, but I'd say Midland radios have the market share as of right now. But, view our website. Go to weather.gov/Riverton. On our website, we put out the hazardous weather outlook on there. We issue that daily. That gives you a heads up for any upcoming weather hazards over the next 7 days. On our point and click map, when we issue a hazardous weather outlook, it will highlight on here, and you can click on your location, or you can type in your city or town that you live at, and then hit go on the website there at the top left-hand corner, and then that will give you your forecast. But when you do that, it's going to give you the hazardous weather outlook information there too. We're definitely going to be highlighting the potential weather impacts and hazards over the next 7 days, and we do broadcast that via NOAA Weather Radio. Within our website also, we broadcast and put that on there, each day the weather story, and that will detail what's going to happen involving high temperatures and weather, especially through that next 24 hours. If there's going to be wind gusts or snow amounts and so forth, that's also going to be highlighted there. And any weather hazards out to 7 days will also be put on there in the bottom key points area of the weather story. So, when there's going to be a significant severe weather event across our area, or a flood event, a winter storm that will produce quite a bit of heavy snow, high winds, and so forth, we will issue what's called a situation report. And this situation report will be, when it's issued, it will highlight in that yellow at the top right-hand corner to the right of our news headlines on our website. So when you see that, when it's in yellow and it says, here's the latest information about the upcoming winter storm tonight through Tuesday, just click on this area up there, and it will bring you to the hazardous weather outlook. You can also go to our local programs, and along with the hazardous weather outlook, you can click on the local programs, and that will take you down to the situation report. And that situation report will contain what's going to be, the outlook in relation, in this example, to involving severe weather across the area. Are we going to have, just strong thunderstorm potential, a minimal, marginal severe weather threat across the areas from Yellowstone down to Thermopolis to Casper? Or are we going to get into a slight severe weather probability, a little bit more chance of severe weather to the north toward Buffalo, Grable, and Cody, north of Cody there in that graphic there? So, we're going to hit on what, when, and where. What's it going to be? What's going to be, happening? When's it going to occur? Give you the best potential timing of when the storms are going to be most active. And then we're also going to tell you, of course, where is going to be the greatest threat there in yellow. And we also have some indicators here to the right that are the severe weather threat levels going from low to high. So you can see with this event, a low tornado probability, little bit toward the medium range for large hail, a medium scale potential for damaging winds, and maybe between low to medium for flash flooding with this event. And we also place in this situation report, what are going to be the most at-risk areas, and also what are going to be the main hazards. In this example, damaging winds to 70 miles an hour, hail the size of quarters, localized flooding, and an isolated tornado with this event can't be ruled out. So we also have within that situation report there some quick facts and resources and safety tips and rules in relation to severe weather hazards, and also some links to the area radars, tornado warnings, local storm reports, and the Storm Prediction Center website there. So we're always on social media, of course, Facebook and Twitter at the National Weather Service. We continue to push information in relation to climate information, convective warnings, tornadoes, severe thunderstorm, flash flooding, anything like that. We're going to try to get updated information on social media as quickly as possible and as long as time permits with the staffing. So keeping that in mind, as we kind of segue the presentation now, I want to talk to you more now about thunderstorms and how they form and what we're going to be looking at as they're going to be developing and occurring. So, taking a look at what creates thunderstorms, you got to have moisture, which is that fuel source for thunderstorms. You got to have that moisture source in the atmosphere, and that moisture source has to be there to create, moisture creates precipitation, and water droplets can then, so many forming together will form clouds. You got to have that instability in the atmosphere, and that's that tendency for the air to rise on its own up into the atmosphere due to heating, the difference between the cold and the warm air across the area. You got to have that lifting mechanism too. That lifting mechanism will be either mountain regions, winds rising up the mountains, orographically uplifting. You got to have the difference between the colder air to the north and west, the warmer air to the east and southeast along a frontal boundary. And, when two thunderstorms begin to die out, that energy gets thrown out in different directions, and that energy comes together and creates another area of thunderstorms. And that's what we call thunderstorm outflow boundaries, which is that energy that rushes away from a dying or decaying thunderstorm, and then more storms can form in that warm, unstable air later. So keeping that in mind, these moisture sources can be anything from evaporation, that's water evaporating from bodies of water and from previous rainfall to the west of us and over our areas. And that can also lead to the other type of source being transpiration from vegetation across the area. You got to have that too in that potential. And importantly, advection, which is winds moving into the area, bringing with those winds moisture. So in this example, majority of our moisture comes inland from the Pacific Northwest, and as that moisture moves eastward, and moves up the mountainous areas to the west of us, they get more of the precipitation, of course, in western Wyoming due to that fact, due to the orographic uplift. And then as the winds rush eastward within the precipitation, in a lot of cases, you get the moisture lessening and evaporating out. But then again, other areas, you get that moisture, what's left over lifts again and creates more precipitation across the area. So The three main areas that we can get moisture moving into our region is from the Pacific Northwest in the monsoon time frame, which is typically that July to August time range. That's when we can get quite a bit of moisture coming in off the Gulf of California and lifting upward to the north into our region. Every once in a long while, if we get a really strong northwest intrusion of moisture and strong winds from the Gulf of Mexico, that could, or a decaying tropical system that's moving up into the center part of the U.S., that could produce just enough and bring enough moisture with it to get into especially eastern parts of the state, maybe toward Casper and maybe barely to Fremont County, but in areas like that. So you got to have that moisture source. Without the moisture, you don't have any clouds, you don't have any precipitation, you don't have any thunderstorms. You got to have also instability. And that's when that pocket of air becomes warmer in that surrounding area. It's going to lift because warm air is light. It's going to rise up into the atmosphere. It is considered unstable, and that gives it a tendency to rise at that point. So warm air is going to rise. It's going to lift that moisture up into the atmosphere, and that moisture is going to slowly cool and form together to form clouds. So you got to have that lifting mechanism too, and that's that. This is an example as moisture is rising up from a moisture source here. In this example, we're just clouds moving west to east. As that moisture lifts up that higher elevation, it's going to lift that warm air is going to rise, and it's going to help create more clouds across the area. So as that continues, that air will rise due to the mountainous terrain and to the east, and precipitation will occur in those areas as it moves off to the east and northeast. A cold front is the dividing line between cold, drier air to the northwest and west, and warm, unstable air out ahead of this cold front. So the clashing of these two air masses create the development and that lifting mechanism along and ahead of that cold front to produce showers and thunderstorms along and ahead of the frontal system. The other third type is an outflow boundary, and that's when you have, in this example, you have one area right here and another area right here of moisture and winds that have been thrown out from this other thunderstorm that's died out. One area is moving west to east, the other area is moving from the east to the west. So as that continues, in this example here, with this outflow boundary, as we call it, this thunderstorm outflow, as that collides together right about there, you're going to get that development along that outflow boundary that can produce, potential for thunderstorm redevelopment in those areas. So keeping that in mind, thunderstorms have a life cycle, and the beginning part of the cycle is your cumulus stage. That's when the sun heats the lower part of the atmosphere where we're living, bottom 5,000 feet or so. Well, as that air warms as the day begins, you get that air becomes warmer and light, so it begins to lift up into the atmosphere. So as that warm air begins to lift, then one drop of water forms together with 5 drops of water to make it 5 drops of water. 10 drops of water then are together. 15, 20, 100, 1,000, depending on the amount of moisture in the atmosphere, maybe a million or more drops of water form together to eventually form a visible cloud. So in that cumulus stage, all you're having is updrafts of wind, as we're going to see here in just a moment. You've got the mature stage. That's when you're getting these updrafts of winds, and then downdrafts of winds along the leading edge of the storm as that storm is moving from the right side to the left side of the screen here. In that dissipating stage, that's when the sun begins to set. You lose that fuel that's building the storm, and when that happens, all that energy that's built up here, 20 to 40,000 feet, it has to go somewhere, so it's going to rush down to the ground as the storm is dissipating. In the summer months, that's when we can get some isolated storm damage, 60, 70, 80 plus mile an hour winds potentially, And when the winds rush down, they spread out in different directions. And it kind of looks like where the damage occurs, where the impact is of the high winds, and it spreads out in different directions. It kind of looks like a bomb has exploded where the damage is. And that's called a downburst. But in stage 1 of 3, involving the thunderstorm life cycle, that's when you're getting that development time period where you're getting just warm air rising into the atmosphere. This warm air, as it rises, it's going to move up above what we call the freezing level, where the temperature is at or below 32 degrees. So when you get to the top of that freezing level, that's when you're going to begin to see these dome-like bubbles that are beginning to kick up at the top end of that developing cumulus cloud. No downdrafts yet. No downdrafts yet. Just updrafts. Just updrafts of wind as that warm air is rising. You haven't had enough moisture into the atmosphere. But once the cloud begins to build up there above 20 to 30 to 40,000 feet, eventually you get so much moisture that's built up here in the mid to upper levels of where that cloud is building, that moisture begins to lean the cloud off to the east-northeast. And when that happens in that process, that's when you begin to get the development of a downdraft. So when that downdraft occurs, you get these updrafts toward the backside of this developing thunderstorm. Winds are rushing in from the southeast out ahead of the storm, and these southeast winds, they're rotating upward to the main storm tower here. This main storm tower is what we call the overshooting top. This overshooting top is a dome-like bubble that extends above the rest of the thunderstorm. It has a cauliflower shape appearance to it. If you see that more than about 30 minutes, it's a good indicator that you've got at least a severe thunderstorm that's going to produce large hail, damaging winds. Well, in this mature stage, you're getting the heating of the sun in the atmosphere is building in this rotating updraft, building the storm upwards of 40,000 feet in the atmosphere. So as that's occurring, you're getting strong winds that are rushing upward and rotating upward. Eventually you get so much moisture up here in this upper levels of the storm, and you're well above the freezing level. So all this moisture up here is a combination of a mixture of rain and hail, and all that gets so heavy that it rushes downward along the leading edge of the storm in what we call the downdraft area of the storm. So you're getting these downdrafts as the storm is approaching. So if you're over here to the right side of the far right side of the screen, and the storm is moving toward you to the right side of the screen here on the image, you're going to feel probably a pretty good gust of wind at and along the leading edge of the storm, maybe 40, 50 plus mile an hour winds. Well, light rain, the temperature may drop 15 to 20 degrees immediately. Then you get light rain, moderate rain, heavy rain directly underneath the main storm tower or that overshooting top. That's where your hail shaft or region is going to be. And a little bit back to the southwest here of that back end of the precipitation area where it's hailing, that's where you run into that rain-free cloud base, southwest corner of the storm. That's the area where you're getting this rotating updraft. And in that area, that's where you can begin to see an isolated lowering of the cloud base, southwest corner of the storm, a little bit back to the west-southwest of that main storm tower, right in here. And where that happens, that isolated lowering of the cloud base or wall cloud, if it forms a funnel, can quickly become a tornado. We'll talk more about that in just a few minutes. But with all things good or bad, they have to come to an end. And that's the same thing with thunderstorms. When you lose that heating in the afternoon to early evening hours as the sun begins to set, well, when you lose that heating, you lose that continued warming in the lower levels of the atmosphere. So no more updrafts. The updrafts are shut off. So once the updrafts are shut off, all of that moisture, heavy rain, hail, high winds that are up here between 20, 30, 40,000 feet, well, it's got to go somewhere. So it begins to rush downward in a downdraft motion at that point, spreading out in downdraft motion. So when that happens, the storm is collapsing. You're in the dissipating stage, and that's the time period where between the mature to the dissipating stage is when you get the majority of your wind damage. And at this point, that's where when we get that downburst occurring in the summer months, that's when your storm is collapsing and dying out and rushing down to the ground. So, the thunderstorm life cycle definitely is what we need to be looking at. But here's some indicators too. This image here shows you that overshooting top here. You see that? If that lasts more than 30 minutes, probably going to be a severe storm. You've got this anvil shape to the thunderstorm there too. That anvil area is where cold, drier air was pushing into the storm. And not much moisture there, of course, because, well, there's no cloud area there. So look toward that backside of the thunderstorm. That's the area where you want to be looking for those striations within the rotating tower there, that rotating updraft. That's where you want to, it gives you like a barber pole appearance there. That's where the winds are rotating updraft in that area. And within that rotating updraft, you begin to get that dry air that's pushing in, and eventually it creates continued rotation. Moisture gets pulled in from the heavy rain area here, and it creates that eventually visible wall cloud. And then you get the funnel developed from the wall cloud can quickly become a tornado. So here's the example of a schematic of a supercell storm. Supercell thunderstorms are the worst type of thunderstorms because they form in warm and unstable air. And then at that point, they'll just continue to move these supercell storms in that warm, unstable atmosphere until finally they work their way into a more stable atmosphere and begin to die out. Some of these supercell storms last more than 200 miles before they finally die out in the worst of events. But if you're spotting, again, southeast winds are rotating toward the front end of that storm in that warm air. These southeast winds are going to push and develop a rotating updraft into that main storm tower area right here, which is your overshooting top. Dry air is coming in from the northwest. There's your rain-free cloud base right here in this area. And that's the dividing line area between that southeast wind motion and the drier air that's coming in from the northwest. That all creates that counterclockwise rotation in the winds that rotate up to the main storm tower, where you get all that hail and heavy rain and moisture up there. Then it leans the storm off to the northeast in most cases toward the direction it's moving. And all that heavy air rushes downward in that leading edge, where you get that cool updraft of wind, downdraft of wind that comes out at the leading edge of the storm, where you may get a 50 plus mile an hour wind gust. Temperature drops about 20 or so degrees maybe. Light rain occurs, moderate rain, heavy rain, and back closer toward this overshooting top area right here. That's where your hail region is going to be. Rain-free cloud base behind the largest hail. And in that rain-free cloud base area, kind of a little bit back to the west-southwest of that overshooting top, that's where that isolated lowering of the cloud base will form to form a wall cloud. All that extends down below the base or bottom of the thunderstorm cloud area. Middle of that wall cloud is your funnel, and when it touches down, becomes a tornado. Moisture in that southeast wind flowing in toward that updraft helps to create a visible lowering of the cloud. Thank goodness we get that. If we didn't get that, we wouldn't know that a tornado was touching down until it had already produced damage on the ground and it created the funnel from the ground up. This way, we get the moisture that's created by the southeast winds flowing into the updraft that creates that lowering visible cloud area, which we call wall cloud. Funnel cloud forms out of the middle of the wall cloud, and when it touches down, produces a tornado. Let's talk about the types of events. Microburst damage occurs within a dissipating thunderstorm. So in the summer months, precipitation falls from the cloud base into a dry layer of air below. As it falls, it evaporates. Through evaporation, the air cools, becomes more dense, and sinks toward the ground faster and faster with time as it gets close to the ground. It hits the ground, is forced outward horizontally in different directions. So, in our area, we get quite a few what we call the dry microbursts because the moisture does evaporate before it gets to the ground. But you still have the really strong winds that hit and impact at the ground level. Obviously, if you can help it, it would be nice not to be directly underneath it when it happens, but sometimes we can't control that. The important thing is when that storm is collapsing like that and we issue a severe thunderstorm warning, move indoors, stay away from windows, and report your severe weather to us. Here's an example of a wet microburst. This was near Las Vegas, produced about 70 plus mile an hour winds, and you'll see here in just a moment. There is the impact. It looks like a big area of water was dumped, but that's where the thunderstorm, dissipated. Quite impressive in my opinion. So here's some more examples of microbursts. Again, all that energy is rushing down to the ground and spreading out in different directions. This is a dry microburst here, more of a wet microburst here where you're getting the precipitation making it down to the ground, another dry microburst here. Lightning is going to occur with all thunderstorms. Obviously, the odds of getting struck by lightning and being a victim is still 280 million to 1 nationwide. Because of our higher elevation here in Wyoming, though, I would say those odds may be closer to about half of that, just because we're in a higher elevation. In the summer months, quite a bit of thunderstorm activity, especially if you're out there hiking in an area where you can't get to safety. That's the thing to be thinking about. Have a safe place to move to. Obviously 43 deaths nationally. The motto with lightning is when thunder roars, go indoors if you can. Nationally, in relation to fatalities weighted by population, Wyoming is in the top 5 nationally, just due to the fact in the summer months between that, typically between June, July, August, and the early September. Each month there could be as many as 3 to 4 million people tromping around here in Wyoming somewhere, and especially west of the divide, quite a bit of visitors and tourism typically. So keeping that in mind, that's where, unfortunately, folks that aren't familiar with the area, they don't know that thunderstorms can pop up quickly in the afternoon hours, and they're not in a good safe place to where they can move indoors, obviously. So lightning is going to strike the tallest object. It does not discriminate. It's going to heat up the atmosphere. A lightning strike, it's going to heat the atmosphere to about 50,000 degrees, which is hotter than the surface of the sun. That rapid heating and cooling of the air near that lightning strike channel is going to cause that shock wave that quickly results in the sound of thunder. Audibly, you can hear thunder in any direction of your location out to 10 miles. So if you can hear thunder in any direction out to 10 miles from your location, you're already in the danger zone at that point. So it's important to move, if you can, indoors to a safe place or to a vehicle. How far away, as a good example would be lightning. So if you use that flash to bang method, that's when you see that flash, you want to count the number of seconds until you hear the bang of thunder at that point. And then divide that number by 5, and that'll give you the number of miles that the lightning is away from you. So with lightning, if you can hear thunder, you're in the danger zone at that point. And lightning does travel several miles, it can, from a thunderstorm. We call those bolts from the blue. And when that does happen, it's important to make sure that when you see it nearby, if you see lightning or hear a rumble of thunder, at that point, it's important to consider your safety at that point. Water is a good conductor of electricity. Stay away from water, of course. Metal is a good conductor too. Again, move indoors, remain in your vehicle with the windows up. No place is 100% safe though, but avoid being that tallest object or underneath that tallest object. If you're caught outside, get in what I call the catcher stance. When you get in that catcher stance, you want to cup your hands over your ears, duck your head, and shut your eyes. And when you feel the sensation of your hair standing up on end, your skin tingling, that's when you want to take a take a quick jog in one direction of not where you're at. You don't want to stay where you're at. Take a quick jog and then duck down and get in that catcher stance. Keep the balls of your feet up off the ground. You don't want to lay long ways across the ground flat, because when lightning strikes, it can spread out in different directions. So you want to make yourself as low of a target as you can, cupping your hands over your ears to protect your eardrum. In a lot of cases, when the concussion of the blast occurs near you, that concussion can burst your eardrums. You want to shut your eyes, obviously, because of the threat and potential for eye damage from the brightness of the blast from the lightning strike. If lightning does strike you and doesn't hit you directly, but it does hit you, it can stop your heart from beating. So if someone knows CPR, they can quickly snap you back into play. But in some cases, there are episodes of neurological damage with folks, and it takes them a while to get back to 100% if they do. So again, lightning is a big danger in the summer months here in Wyoming. Hail is a very most destructive element here. It's going to rarely cause fatalities, but just picture this size of hail that you're seeing on the image there, dropping out of a thunderstorm from 30,000 feet and falling down to the ground at a speed of 100 miles an hour. So picture the fastest Major League Baseball pitcher throwing you a fastball from 30,000 feet. That's pretty much what's going on in this example. Lightning causes nearly $1 billion worth of damage to property and crops annually. So hail did produce one of the largest hailstorm damage-wise. It did occur near St. Louis, Missouri, April 10th, 2001. About $2.3 billion worth of damage. Vivian, South Dakota has the distinction of having an 8-inch in diameter hailstone. So in this example, you can see there's a hailstone, there's several hailstones that form together in that up and down motion within the thunderstorm. So, the thing to think about with hail, if the sky has a green shading, where that green shading is, it's where it's hailing. The green shading in the afternoon hours, especially if you see that, that's the sun's rays reflecting off the hailstones, creating that hue or color. And if it's moving toward you, obviously it's going to start hailing pretty soon. And if the hail gets larger and larger, if it gets up above tennis ball size to golf ball size hail, then at that point I would definitely be keeping a watch out. So in this image here, you'll see in the video, they're getting up to about golf ball size hail here. A little bit back to the southwest of there, toward the back of the screen. And this is an example I want to stress. There's your tornado, following the largest hail by about a minute or less. I've been involved in a couple of events in my life in the Tennessee Valley region where I used to live, in Tennessee, Alabama, Western Kentucky, where you have the large hail approaching, and when it happens, directly back behind the largest hail to the southwest is going to be, as it was in this image here, that's your tornado approaching. So just keep that in mind. It does, believe me, work like clockwork. So, with hail, get indoors, stay away from your windows, and if you're outside and have nowhere to go, get in that vehicle. Your vehicle is going to carry you with enough protection up to about golf ball size hail, but anything above golf ball size hail, who knows at that point. When I used to live in North Texas, when I worked at the National Weather Service there in Fort Worth, we would, if a hailstorm was approaching and I was out driving, the thing I would look for would be a location where you could get off the road, get your vehicle off the road, and that could be a car wash. You could pull that vehicle right into a car wash area, the not the automatic ones, but the ones you spray yourself, and that could give you just a little bit of protection as that large hail is approaching. So flash flooding is defined as a rapid rise of water within a waterway or a normally dry area. When flash flooding does occur, it could occur within a few minutes or even a few hours of the rain event after the event's over. So the important thing is, if water is covering the road, and starting to form across the road, you know, it definitely would be iffy to drive through that. It can happen where little or no rain is occurring. And, watching this example, this is 1 hour here. You can see highlights there of the road still. But by the next hour, whoa, where did the road go? At that point, definitely not something you should drive through. All it takes is about water that's about your knee level or higher that can lift up and carry you off if you get out into it, and it can also carry off a vehicle. And once you're buoyant there and the water is rushing at a strong current, there's no telling where you're going to end up. And unfortunately, that's what happens nationwide each year. And flash flooding kills more people than any other weather hazard related to thunderstorms combined across the U.S. So remember this motto: when thunder roars, go indoors for lightning, but with flash flooding, it's turn around, don't drown. So it seems like, we've developed some mottos for about every severe weather event. So again, that turn around, don't drown means it's important to turn back around, maybe go back the way you came, and stay in that higher, elevation area where there's not going to be flooding. Do not attempt to walk or drive across that flooded roadway. Again, water, about 2/3 of the way up your tires to beginning of getting up to your door, that's really going to begin to lift up and carry off a vehicle. So some states have, turn around, don't drown flood laws. So if someone passes through these barricades or cones that are up intentionally and tries to drive into a flooded road, and then they have to be rescued by law enforcement, they're probably going to be cited at that point. And depending on how mad the person is that has to get you out of there, they have the ability to make you spend a night in jail. So in some states, I know it's like that in Texas and Tennessee, and there's a few other states where they have the turn around, don't drown flood law. So it's designed to make sure that people, even the ones that are in SUVs or minivans or trucks, thinking, oh, I can just make it on through that. That's no big deal. Well, it is a big deal because water flowing like that, and like what you're going to see in this image here, will definitely lift up and carry off a vehicle.
Oh my God.
Once it's in that water and the water has control of it, you've lost control. That's the issue.
We probably want to just stay.
That's a good idea. And I think in this example, they are too close to the floodwaters at this point.
I want to get out. No.
There will be another one coming here just shortly.
Oh my God, it's crazy. I mean, they have no control at all.
That's correct. Well, not a tsunami, but it is a flood event. Tornadoes are violently rotating columns of air that are in contact with the ground. As a tornado moves into the area, you can see here, it's going to pick up debris as it first begins to form. This was the very first image ever photographed of a tornado. This was photographed around 1870 in Oklahoma, of course. Back then, they had the, shortly after the Civil War era, they had the really large, as you may have seen in some of the old westerns, the large photography equipment where they actually would get their heads underneath behind the camera there, and they had the big plates that they would put in there. Well, I can tell you, by them taking an image or a picture of this tornado and it coming out that well, that definitely tells me that they were pretty close to that tornado, probably a little too close for comfort. So in this example, you probably had one tornado that had already lifted as the tornado's moving off to the right. This tornado, within that supercell storm, as I was mentioning, that tornado began to develop and touch down and became the dominant one as this one weakened and died. And this may be the one that further down the road is going to take over as the dominant portion of this supercell storm when this tornado begins to weaken and die out. So a tornado, again, violently rotating column of air that's attached to a thunderstorm and in contact with the ground. Tornado like this has been on the ground for several minutes because it's had plenty of time to lift up in that rotating updraft, plenty of moisture to create that strong, large funnel as it's moving along. The bottom image here is the precursor to the tornado, or before the tornado, which is the funnel cloud. That's a rotating funnel-shaped cloud that is not in contact with the ground yet. If that bottom end of that funnel gets down to about 2/3 of the way down to the ground, well, when it touches down, it will likely touch down about 70% of the time if it gets down that low. But right now, still got a ways to go in this image before it becomes a threat. But still, we want to know if you're getting the development of a funnel cloud, because it can quickly do that, which is touch down and become a tornado. Please let us know. This is in the sequence. This is before the funnel cloud. This is the wall cloud. This is your isolated lowering of the rain-free cloud base, southwest corner of the storm. In this portion of the storm, this is the base or bottom of your thunderstorm. All this extends down below that base or bottom of the thunderstorm area. In the middle of this wall cloud toward this area right here would be where I would be watching for the development of a funnel. And if it does touch down, that'll be probably in that directed area. The front end of that wall cloud is what we call a tail cloud. The tail cloud is sloped and pointed toward the heavy rain and the hail that's off to the east-northeast of it. So what's going on is these southeast winds and the warmer air, it's pushing that moisture and lifting it into this region here where your rotating updraft is occurring, and it's creating that moisture flowing in and tailing in toward the wall cloud is producing that wall cloud area. So that gives us a little bit of a heads up, of course, that something is going to be forming here in this part of the storm. Is a precursor to the funnel cloud to the tornado. Here's a better image of a wall cloud. This wall cloud area here, all this extends down below the base or bottom of that thunderstorm cloud area. That tail cloud is sloped and pointed toward the heavy rain. A better example in this image, you can see the moisture just trails in from the southeast toward that wall cloud area. Toward the middle of that wall cloud is where your funnel forms. And if it becomes visible and you have debris flying up and you can see that, then that's when you have the tornado touching down. If you can't see the debris and really get a good indication that the tornado is touching down, call it like you see it. You can say, hey, I've got a wall cloud with a funnel attached to it, funnel cloud in that region. Could be touching down, just can't see because of the tree line or the mountains behind me or in front of me. It may take a minute or two again before I can tell for sure that the tornado is touching down. Could be a tornado, but that's a good report because maybe there's someone closer to where that's happening that we could find out more information from that could help verify the severe weather occurring. So, shelf clouds form along and ahead of a line of thunderstorms, while a wall cloud is going to form on the, sorry, talking like this is tough, but along the backside of the thunderstorm toward the southwest is your wall cloud region, isolated lowering of the cloud base, southwest corner of the storm. Heavy rains on the right-hand side here, large hail right here. That moisture is spreading in toward that rotating updraft here. From that area, that's where you get that isolated lowering of the cloud base, southwest corner of the storm, and could form to a tornado. Along that leading edge of the thunderstorm area, that's that example I wanted to show you now of a shelf cloud. That's along that leading edge of that downdraft region in the thunderstorm. So what's going on? You're getting strong winds that are rushing downward, that heavy rain that's going to produce cooled air and that downrush or downdraft. And that motion the heavier air, the definitely the colder air is going to be heavier than the warm air. It's going to be rising out ahead of it. So that colder air is going to cup these clouds up and under in that turbulence, and it's going to create that shelf-like appearance within the clouds along the leading edge of that line or area of thunderstorms. So, wall cloud is going to be on the back side of the thunderstorm right before the storm ends. Shelf cloud is going to be on the leading edge of that line of thunderstorms. So with that, the worst is going to be the first part of the storm. In this example with the shelf cloud, you're going to have strong winds rushing downward, 50 plus to 60 plus mile an hour winds at times. It's going to undercut that warm air that's going to lift, and that motion will continue as it rolls along. So you're going to get a really strong downrush of winds, and this is damage, like what we talked about a while ago. The downburst has winds rushing down and spreading out in different directions. The shelf cloud is your second type of wind damage, which would be, the winds rushing downward at that point, cupping these clouds up and under. You're going to get, with a shelf cloud, winds moving along from west to east or northwest to southeast along that line of storms. So, the damage is going to be orientated from the direction the storm is moving from. So everything's going to be blown in what we call a straight line, or what we would say straight line wind damage. Of course, the third type of wind damage occurs with a tornado, where you have rotating winds along the axis of the tornado in a concentrated path southwest to northeast at average forward speeds at 30 miles an hour. Here's a good example of a shelf cloud from Idaho Falls, Idaho, April 2010. In this example, that shelf-like cloud will form as it's approaching, and that's where, the worst will be the first. They'll get the strongest winds along and ahead of that line of storms. It'll push through. Heavy rain will occur in the dark area and the thunderstorm behind that immediate shelf-like appearance. And then the storm's over. So it may only last about 10 minutes or so, but you can get strong enough winds to produce wind damage. So let's talk about tornadoes more. Tornadoes are rated in the form of weak, to moderate to violent tornadoes. So weak to strong to violent. In this example, your EF0 to EF1 tornadoes are about 69% of all tornadoes that occur. Thank goodness, if we have to have tornadoes nationwide, almost 70% of them are the small ones. They're going to produce some minor damage, to your roof, knock over some trees and things like that. Less than 5% of tornado-related deaths, 1 to 10 minutes of time on the ground, path length up to about 3 miles in length. Wind speeds ranging from 65 to 110 miles an hour. Thankfully, further in our area, about 80% of all the tornadoes that do occur are the weaker tornadoes, the EF0s and 1s. But any tornado, when it's on the ground, is considered dangerous and potentially deadly. Keep that in mind. When you get toward the strong tornadoes, these are the 2s and the 3s. 29% of tornadoes nationally, 25% of all tornado-related deaths. Those type of tornadoes, the strong tornadoes, could be on the ground as much as 20 minutes or more. More concentrated rotation within the tornado, path length 15 plus miles potentially. Wind speeds on the low end, 111 miles an hour for a 2. When you get to 135 miles an hour with the wind, that gets you into the EF3 range, up to 165 miles an hour. EF2 is going to take your roof off, basically. A 3 is going to take your roof off, and most of the rest of the house will be in rubble, except for your most interior walls. So that's why we say in our tornado preparedness, move to your most interior part of your home. 4 good sturdy walls. That should be in relation to the direction the tornado is moving toward you from. So, that's another 13% of our tornadoes. So that's 99% of the tornadoes are the strong to the weak ones. So thankfully, About all of our tornadoes are the weak to the strong ones. And then you've got the worst ones, which are your violent tornadoes. 2% of the tornadoes nationally, those are the worst, produce about 70% of all tornado-related deaths, obviously, because the safest place, excuse me, away from a tornado like this will be either out of its path or underground at that point. So, they can have a lifetime over an hour, have a path length of greater than 50 miles. I've tracked a couple tornadoes in my career that have been on the ground more than 100 miles. April 27th, 2011, as I call it, the super duper tornado outbreak that occurred in the southeast part of the U.S. We had a couple of tornadoes that were on the ground at least over 100 miles, produced incredible damage. When you get to the 4, that's 166 to 199 on the wind speeds. When you get over 200 miles an hour, the difference between a violent 4 and a 5, a 4 is going to produce rubble like this. You can see from the previous image here at this location there in Roanoke, Illinois, in this example. This manufacturing area was reduced to rubble. Well, if it gets to the 5 range, it's not going to only reduce it to rubble, it's going to wipe it clean. So that's the difference between a 4 and a 5. They're very rare when they do happen, but they can happen. Our only tornado in our area was between the Teton and Yellowstone National Parks areas that achieved the EF4 range, wind speeds over 165 miles an hour, that occurred on July 21st, 1987. Here's a look at all of our tornadoes across our area from 1950 to 2019. You can see we're getting a lot of reports, in some of the more populated areas because that's where people are. And, I have sense to believe when you get to about central Natrona County, kind of the southeast part of Johnson County there, you're probably, and down here into eastern Sweetwater County, that's kind of on the far western fringe of the Great Plains tornado outbreak regions. So, we do get smaller reports of tornadoes across our areas, and especially in the valley regions here. I think a lot of that has to do to the terrain features that help create these spin-ups when they do occur. So, if people think that there are no tornadoes in Wyoming, they're definitely mistaken. There are quite a few, and I'm sure there are probably quite a few tornadoes, especially in some of the unpopulated areas that we do miss getting reports about, and there have been several warnings that we just know that there were tornadoes based upon what we were seeing on radar. We just couldn't get the reports, couldn't get verification because A, there may not be any trees, and B, there were no people there to report them. So that's your importance to us. So 170 exactly tornadoes have occurred between 1950 through 2017, and you add another 4 to that for the last couple of years, that'd be 174. 71% of them occur between 2 and 7 p.m., which is in our time of maximum heating, and that does make sense. And of course, the strongest was in the Yellowstone Teton region. Landspout tornadoes occur when updrafts within a developing cumulus cloud help to stretch the atmosphere just enough from the ground to the cloud base. And that air converges at the surface under that developing updraft, and it can form a short-lived developing tornado there when you get that little bit of debris there. It's going to be very short-lived and a very small tornado when it does happen. The other thing I want to stress with that is looking at tornado lookalikes. Those are some of the biggest challenges that we have involving tornado spotting, is determining whether, we are seeing the real thing or not. Look for that debris cloud near the ground, organized rotation on the vertical axis. That's the important thing. Watch what you're looking at several minutes to make sure you're seeing what you're seeing. In this next image here, is this a tornado? And the answer is no. when this person was looking at this image of the low floating clouds moving along, he realized, hey, that's pretty close to where I'm at. I should be hearing, some sort of damage or debris or roar from the tornado, number one. Number two, as he looked, he realized, well, these low floating clouds, they're not attached to the thunderstorm off to the west above it. So they're just some low floating clouds that we call scud clouds. Watch it for several minutes. You'll know the difference. Definitely. Look for strong rotation of the winds, lower levels of the atmosphere there. Virga, which is evaporating precipitation before it makes it down to the ground. That's another example that can fool folks. Initially, they might think, boy, that's a pretty good sized developing tornado there, when in reality, it's just evaporating precipitation. Knowing where that is in reference to where it should be producing a tornado also is important too. If in this example, this virga is along the leading edge of the thunderstorm, that's not going to be the area where a tornado will form. A tornado is going to form on the backside of the thunderstorm, right before the thunderstorm ends. Not a good way to end a thunderstorm, in my opinion, but we don't have any choice in that, of course. Looking at smoke from a fire can definitely fool you initially. You might think, is that a funnel cloud extending down and touching down there? But the longer you look at this thunderstorm area behind it, you realize, well, it's just moving right along, but nothing's changing. This is still in this direction, maybe due to the orientation of the winds that's creating this look. So the longer you watch it, you realize could be just a distant smoke column, or what we might want to affectionately call a smoke nado. So keep that in mind too. A dust devil is not a tornado. You could have clear skies up here, but you're getting a little bit of rotation in the winds and that instability that's creating that rotating wind there, but not going to be a tornado, not going to produce any real damage. I have seen a few dust devils that have lifted some hay bales and so forth, the smaller ones especially, but it's definitely going to sandblast your vehicle if you drive through it, probably, but it's not going to really produce much in the way of any damage per se. Involving spotter safety, we don't encourage mobile storm chasing. Please try not to do that. And in these days, with what we're dealing with COVID-19, I would just love it if you guys would just be, just point spotters from your location. That's important. If you're inside, go to that basement. That's your most safe place to be. Underground, most interior closet, bathroom, 4 good sturdy walls. If you're caught outside, have nowhere to go, and you're driving along, the thing you have to make that as a personal responsibility issue with yourself at that point. Do I want to risk trying to outrun this tornado and not be able to do it? Is it going to intersect me? Am I south of the tornado? Is that the best place to be? The answer would be yes. And, if I'm going to intersect that tornado, obviously, and it's looking like I'm going to be in a bad spot, you have to make that decision. Do I want to stay in my vehicle, or do I want to get out of my vehicle, get into a low unflooded ditch, cover my head, and hang on the best that I can? If you can find a concrete culvert, that might be even better. But the thing to think about at that point is, what's going to be the safe place? If you're in the vehicle, you're the tallest object and you're above ground level too. If you're in a low unflooded ditch, you might be able to hang on enough potentially to make it. But that's going to be the real issue at that point. You're in a bad spot either way at that point. So, just be familiar with your area. Have a planned escape route if you have to. I tell folks, if you're driving along your normal route to work each day and you're coming home in the afternoon, have 3 to 5 locations along your normal route home already predetermined so that you can get off the road at a moment's notice if a tornado is spotted or a tornado warning is issued where you're at. So you can move maybe into a more interior, stronger shelter or a building and to wait it out until it passes by. That's the important thing. So, at home, if the tornado is moving from southwest to northeast, you don't want to be on the southwest part of your home because that's where it's going to hit first. You want to be in that most interior part of your home there and have, 4 good sturdy walls around you. Have as many walls between you and the high winds. That's the important thing. Folks that have, I hate to say, from looking at a lot of tornado damage over the years, at hundreds of tornadoes in my career, looking at tornado damage, if a home is facing to the west or southwest, the tornado is moving southwest to northeast. What it does in a lot of cases, the winds will hit that garage door, it will buckle in the door, pop the top off the roof, and then there goes half of the roof of the home. Homes that are facing away from the normal direction of the winds that the tornado approaches from, they're the homes in a lot of cases that do have lesser chance to be as damaged. But that's not to say, any home can be damaged just as bad as the next if it's a strong enough tornado, but especially with the smaller ones. If you're in a mobile home, I recommend get out of that mobile home, move to a safer place. Make a buddy next door that may have a basement or a brick home or something like that, and maybe drive to a safer place if you have time. That's the objective at that point, is being as safe as possible. So here's an example of these storm chasers. Please don't do this. I just need to tell you, in this video, they are too close to this tornado. They end up there. We don't need that report that bad. We really don't. See, they're close. They're too close because there's a lot of debris that's flying close by to them, and anything could happen at that point. Probably about a mile or so from the tornado, about a mile and a half to 2 miles. See, that's just way too close to this large tornado. A lot of that debris can fly numerous miles away from the tornado. You see, there's something big toward the end right there. Right there. You don't want to be in a vehicle that close to it and a big tree or piece of a roof comes flying down through there and whacks you at that point. That would not be good. So, last year's tornado, Powder River passed. Thankfully, we'll just continue on with this season. This was some large hail in Thermopolis. Had 1.5 inch diameter hail to 2 1/4. That occurred around 1:50 p.m. on July the 1st. Did some damage to siding, broke some windows. This was the Marbleton tornado that occurred. This tornado was about 20 yards wide. I mean, it was barely on the ground, not much more than a couple of streets when it did touch down there, April 26th. Barely on the ground, barely gone. Little land spout that touched down, and it was over. Undetectable. These type things, when they do happen, they're very hard to spot. So let's bring ourselves up now to what do we report, involving severe weather if you're a spotter. How do you report it? And who are you going to call? Obviously not Ghostbusters, right? This is what I want you to report, if you could. Report a wall cloud, a funnel cloud to a tornado. Hail of any size and diameter, of course, we want to know about, because hail can increase in intensity maybe a few miles down the road from where you're at. So we can gauge that as the storm is increasing. That helps us at the Weather Service. Wind gusts, if you can record it or estimate it, 45 mile an hour or greater. Severe threshold is 58 miles an hour for thunderstorm damage. Any flash flooding, any water over the road, anything like that we want to know about. If you have a rain gauge, you have greater than 1/2 inch an hour with the terrain we have, it's probably going to produce some flash flooding. So, any damage that you can spot or see, trees, power lines down, or structural damage, we definitely want to know about it. Make a mental note of what time it's occurring. We want to know that time, not the time you called it in to us, okay? And again, I'm going to be sending you guys some spotter cards for everyone that registered tonight, and also some other information. So you'll have the 800 number on that. So, Skywarn spottings year round. Please help us with the winter reports involving snow. Take several measurements in an area where it's flat and uniform. and average it all together, and that will be your amount that you would have. Any type of ice jams, if you notice it when you're driving along and you see an ice jam occurring off the side of the road by a river, please let us know if it's jamming up, because that can produce flash flooding pretty quickly. So, we want you to report it. You can report it and call us anytime at 1-800-211-1448. Identify yourself and your location. So you could say, hi, I'm Tim Troutman. I'm a trained storm spotter. I'm 3 miles west of Riverton. It's 7:35 p.m. Tornado has just touched down. It's moving northeast at 30 miles an hour, you estimate. It has destroyed several buildings in its path. So, knock on wood, let's hope that never happens. But what we need to know involving that is if you could give a reference to the nearest town or significant location that folks would know, that would help us so we could better gauge where the damage really did occur. We want to know exactly what time the event did occur when you're spotting it, reporting any damage and any changes in the storm's behavior. So if it increases in intensity and gets worse and worse, please continue to call us. It's not going to bother us. We want to know so that we can warn others further, from the direction that it's been moving from, and you hope that it's been happening several minutes before it's reached your location, so you've had plenty of time to get an advance warning that it's coming. So express your uncertainty too. If you're not sure, say you're not sure. This is what I got. You make the call. You're the umpire. So, we also monitor Facebook and Twitter. And, if you're posting pictures and video on there, we'll, in most cases, hopefully get a shot at that. You can share it with us, to us, and so forth, and send it to us that way. That would be greatly appreciated. We will give you full credit, of course, for the image if it's usable, and we would appreciate that if you'd let us use it. And we would definitely put courtesy of your name and so forth, and that can help us for future storm spotter training classes, so that we can use good examples of pictures or video. But the number one thing I want to stress more than anything is spotter safety. Safety's number one. So that's the important thing. So as we're wrapping up, let's have a test now. Let's test our knowledge and see what we've got. So what type of product would be issued if conditions were favorable for a severe weather event in the next 6 hours? Location and timing still uncertain. Would it be a warning, a watch, an outlook, or an advisory? A warning is in the next 45 minutes. An advisory can be out to a day or two, potentially. An outlook can be out to 7 days. But a watch is out to the next 6 hours. So the correct answer is a watch. Which of the following is an indicator of a strong updraft in the thunderstorm? You got to have that rugged back edge to it. It's going to be a vertically erect structure there, the up and down motion in the storm. Rotations or striations within the storm, overshooting top, or all the above. Well, if you've taken a lot of tests like I have in my career, it's going to be all the above in this example. So that is the correct answer, all the above. The diameter of quarter-sized hail, quarter size, not quarter-inch hail, quarter-sized hail is 1 inch in diameter. Please be very careful with that if you could when you report that in. Say, I've got quarter-sized hail. Not, if you say I've got quarter hail, well, is it quarter-inch hail or is it 1 inch hail? Quarter-sized hail will be 1 inch in diameter. According to the flash to bang method, how many seconds does it take for thunder to travel 1 mile? So utilizing the flash to bang method, the correct answer is 5 seconds. So on to the next question. What should you report? Funnel cloud, wall cloud, tornado, flooding. If that's going on, any size of hail, winds above 45 miles an hour. If all that happens and produces trees, power lines, power poles down, the correct answer would be you should report all the above. So with that, here's a good example here of what we talked about involving lookalikes. So looking at this closely in this image, you realize after looking at it for a few minutes, Well, hey, that's kind of out ahead of this thunderstorm that's in behind it. So it's not attached to the thunderstorm behind it. If it's not attached to it, it's not going to be a funnel cloud. It's not going to be a wall cloud. It's not going to be a shelf cloud. So it's going to be a scud cloud. So with that, what is this? Is this a funnel cloud? No. Is this a shelf cloud? No. Not enough turbulence, not along the leading edge. Storm is moving toward the right of the screen. This is the back side of the thunderstorm here. So this is not a tornado yet, not a funnel cloud yet. Funnel cloud would be in the middle here. So this is what we would call it before it's a funnel cloud, a wall cloud. And then finally, funnel cloud, of course. Shelf cloud, no. You're on the back side of the thunderstorm. Thunderstorm's over here. There's your heavy rain, large hails here, isolated lowering of the cloud base, southwest corner of the storm. Your funnel cloud forms from the wall cloud, and you might be hard to see, but there's some debris flying up. So with that debris flying up, that means you've got a tornado that's touched down. So, please report weather to us. If you're not a community collaborative rain, hail, and snow network reporter, or what we call CocoRAS, please do join this. All you need to have is a rain gauge. So you can get a plastic 8-inch rain gauge, and each day you could definitely, if you could report that information into us after you record it. Just go to cocoras.org, and you can be part of the CocoRAS network. And we take and we really appreciate those spotter reports each day. Really helps us. So, with that, I just want to thank you guys so much for participating tonight and taking time out of your busy schedules. And again, there's our 800 number on the screen, 1-800-211-1448. And go to our website, and that's at weather.gov/Riverton. On Facebook, you can search us at NWS Riverton, and Twitter at NWS Riverton.